Hello everyone, welcome back to my channel. Today let's learn the chapter sets. Okay, for class 11. The main topics we'll discuss today is the empty set and the finite and infinite set. Okay, firstly, what is an empty set? Can you define? Yes, a set which does not contain any element is called the empty set or the null set or the void set. Okay, is a set which is not having any element, nil. That is nothing but no elements is called the empty set, or we can tell it as a null set also. The empty set is denoted by the symbol. So this is the symbol of an empty set, or we can write this flower braces with no elements. Okay, then just see the picture here. This is an example of the empty set. Okay, as empty set has no elements, its cardinal number is always 0, and see the symbol here. Okay, this is not an empty set. This is a set which contains some elements, that is 6 elements. We have some fruits. Okay, a set of fruits with 6 elements, and the cardinal number is 6. You see here an empty set with no elements, and the cardinal number will be here 0. Okay, it is also called what set? It is also called a void set. Okay, remember this. Okay, a set of 5 numbers, that is nothing but 2, 4, 6, 8, and 10. This is what? The set of cardinal number. Set of 5 numbers. This is a cardinal number 5. Okay. Then here you see in this example there is no element. So we call it as null set or an empty set, and the cardinal number here is 0. Okay. I hope you have understood this with an example. Now we will take some examples and understand it more clearly. C is equals to x is an even prime number greater than 2. Now tell me if this is a null set or no. It is an even prime number greater than 2. You have any number? What are the prime numbers? Firstly, number which is multiplied only once. Okay, and even prime number is what? Only one number, that is 2. They are telling that we should get the number greater than 2. Even prime number greater than 2. There is no even prime number greater than 2. So the elements in that set will be 0 elements. Okay, so then we call the C is the empty set because 2 is the only even prime number. Okay. Next one you see. D is x is to x2, and that is equals to 4. X is odd. Now tell me, this is an empty set or no? No. Yes, it is an empty set. Why? Because they are telling the value of x should be odd. Eh, Here, whatever you do, the value will not come as odd. 1 square is nothing but 1 only. 1 square is, now 2 square is what? 2 square is 4. So the answer is odd. You can't take the other numbers to get the value of 4. We can't square the other numbers. Only we can square the even number. That is 2 square is equals to 4. With odd numbers, we can't get the answer as 4. So we tell D is again the empty set. Okay, is not, the equation is not satisfying by any odd value of x. Then next example, see. So next, see the third example. Consider set A, that is x is to 3, and where x is nothing but lesser than 3, lesser than 4, and x is what? It is a whole number. Now you tell me, it is an empty set or no? Yes, this is an set A is an empty set because there is no whole number between 3 and 4. Okay, x is lesser than 3 and lesser than 4. Then you tell me, between x there is no whole number. So it is a null set. Okay, I hope you have understood this with an examples. Okay, now let's see the finite set. What is a finite set? A set which is empty, or it consists of definite number of elements is called the finite set. Okay, it should have some particular number of elements in the set. if for example, I can just give an example of vowels, that is English alphabets. A, E, I, O, U. These are what? These are the vowels of English alphabets, and we are having the particular number in that, like definite number, only 5 letters. They are the vowels. Okay, this is the that set is nothing but the finite set. Okay, then next we'll see some examples. See, consider some examples. Let W be the set of the days of the week. Okay, days of the week are Sunday, Monday, Tuesday. Okay, we are having 7 days, and these are what? Definite number. They will not be changed. Okay, so we call this set as a finite set. Let S be the set of the solutions of the equation. That is x square minus 16 is equals to 0. See, we know after solving this equation, we get two roots. Okay, x plus 4, x minus 4. We know that we are having, we get after solving the equation, we get particular two roots. So we know that some finite number is there. So we call S is a finite set. Okay, next we'll move on to the other set, that is infinite set. A set which consists of indefinite number of elements is called as the infinite set. See, in the word only infinite is nothing but infinitive. There are so many numbers. We don't know how many numbers to be. Can you see here in the example? See, 1, 2, 3 dot 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 1, 3, 5, 7 dot 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 dot. That is nothing but the infinitive. We don't know the exact number. We don't know the particular number. So this set is called as the infinite set, where we don't know the number of elements. We have so many number of elements. Okay, practically I can give an example of our head is having so many hairs, we can't count. That is nothing but our infinite set. Okay, let's see some examples. See here, 1, 2, 3 dot 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 dot. This what is a set of natural numbers. Okay, there are so many natural numbers, we don't know how many are there, infinite. So it's nothing but the infinite set. Next, 1, 3, 5, 7 is a set of odd natural numbers. Again, there are so many odd numbers. Okay, so this is an infinite set. Minus 3, minus 2, minus 1. This is a line of integers. Okay, 0, 1, 2, 3 is a set of integers. There are so many infinite numbers, integers. So we call this again as an infinite set. Okay, the next important point is that, see, all infinite set cannot be described in the roster form. Okay, see, we have described here in the roster form the before examples, set of natural numbers or set of odd numbers. So some infinite sets cannot be described, okay, in the roster form. For example is the set of real numbers. Okay, cannot be described in the roster form because all elements of this set do not follow any particular pattern. Okay, they are not following any particular pattern, it can go on however it want. So all the infinite set cannot be described in the roster form. You should remember this point. Okay, now let's see some examples. Okay, state which of the following sets are finite or infinite. Okay, let's read the question and just discuss which is a finite and infinite set. X is to x belongs to n, and x minus 1 is to x into x minus 2 is equals to 0. So now we'll put the value of 1 in the place of x. 1 minus 1 is what? 0. 0 into anything is 0. So this is equals to 0. So the equation is satisfying. Now next you put the value of 2. 2 minus 1 is what? 1. Again here 2 minus 2 is 0. 0 into anything is 0. So we are satisfying the, it is equals to 0. Okay, so it is what? It is a finite set. We are having two numbers, 1 and 2. Okay, the next question is x is to x belongs to n, and x square is equals to 4. See, we know one particular number, that is 2 square is equals to 4. So one number, that is 2, is the value of x is 2. You can't take 3 or 4. We know one definite number, that is 2. So again in our elements are 2, and hence it is a finite set. The next question is x is to x belongs to n, and 2x minus 1 is equals to 0. See here, none of the numbers will be equal to 0. If you put the value of 1, x as 1. 2 into 1 is 2. Minus 1 is what? 1. So it is not satisfying the answer, that is 0. It is not equal to 0. No numbers will be equal to 0. So if nothing is satisfying, what do we call this set as? There is no elements. We call this as a null set. So null set is nothing but it is again a finite set. Okay, you can tell is this as a finite set. Okay, next, x is to x where n and x is a prime. There are so many prime numbers. We don't know how many there are. There is no definite number. So the given set is a set of all prime numbers. And since the prime numbers is infinite, the given set is infinite. Next question is x is to x does not belongs to n and x is odd. Now again, since there are indefinite number of odd numbers, the given set is what? Infinite. Okay, you have understood. I hope you have understood the finite and infinite set. Okay, the next example, we will take the examples of null set. Now tell me which of the following examples are of null set. Set of odd natural number divisible by 2. So what are the numbers divisible by 2? That is odd numbers. Can you tell? No numbers is divisible by 2. Odd numbers are what? 1, 3 and 5, 7. They are not divisible by 2. We cannot divide it by 2. So we call this as a null set. There are 0 elements in the set. So this is a null set. Now next, a set of even prime numbers. What are first even prime numbers? There is no even prime numbers. Only even prime number is 2. Okay. Now they are telling set of even prime numbers. We are having one number, right? Even prime number, that is 2. So that is not a null set. There should be 0 elements in the set. Then only we call it as a null set. We are having one number, that is 2. So it is not a null set. I hope you have understood the finite and infinite set and the null set. Please do not forget to subscribe my channel and like and share my videos. Thank you.